Twitch is also updating. Yeah, there we go. Okay, cool. Twitch is loading in as well. Sweet, sweet, sweet. Yeah, everything seems to be working as it should. Okay. Right, so the thing I want to address today for the stream, right? So if we run the Raytracer now, we can see that the following happens. Right, we can see that the texture is kind of working, but there's still quite a bit of artifacting, and we can clearly see the shading is doing something weird, right? It's almost like the light is moving as well. What is weird? So that's one of the things I want to fix today, because if this is fixed, then it will also lay way for a bunch of other things with transforms. Right. So I figured out last time what was wrong with the textures, why it was doing this, so now I actually have a good idea how to fix this. So hopefully this shouldn't take too long, but we will see. Right, so the first thing that I want to do in the ray tracing, I want to add a new struct here, a private struct. And this is going to be hit info. And this will contain some information for the all the functions that are going to go to know what we actually hit. So we're going to have a, we do need GLM in here. Why is this complaining? Actually, before we do that, I'm just realizing, since we switched to Clang, we get the pragma warning thing isn't going to work anymore, I think. So let's get rid of these files. Right. So pragma once. This is the header file. Interesting. So what would you suggest me to do? How is this a main file? Is it because it doesn't have classes? Okay, interesting. Right. Oh, okay, this is actually fair. That's a good fix. Right, but it's presumably been declared as a struct. Okay, so somebody somewhere struct camera. Ah, that's a shame. I can't just find the. I mean, I could do struct camera, and yeah, there we go. So this is actually a class, right? Fopen is deprecated. Yeah. Okay. So we want to do. I forgot how we suppress warnings with Clang. So let me Google that real quick. Clang suppress warnings. Right. Yeah, right. So there are multiple methods of doing this, but I want to do the. I want to use the macro way of doing it. Right. So, pragma ccg. Right. Push, and then pulp at the very bottom. Right. And then I want to ignore. Not this, but I want to ignore. They deprecated declarations. Right, I think that should be good. And if we then recompile, we should see errors, or should get rid of some errors. Right. Okay, now we actually have an error. Interesting. How did we magically get an error? No, the build succeeded. Okay, wait, let me just do a full rebuild. Maybe that's weird. Okay, very interesting. I don't know where it's coming from, but that's fine. Because this output is like insane, right? So let's just go one by one. So this one, warning. Right. So that's actually a good variable because there should be channels instead of 3. Yeah, that's fine. Okay, cool. Next one is unused channels. Yeah. Unused channels. Okay. Non-portable file. That's fixed. Warning, integer division. This is STB image. Right, so I include STB image in, I think, material. Is there material.cpp? No. Oh, it's the texture.cpp, I'm guessing, yeah. So this would be hashtag pragma clang, or I think there's actually a specific, because clang knows them for both things, but I'm wondering if it takes pragma clang. I know GCC works. I know clang recognizes both. Diagnostic push hashtag pragma GCC diagnostic. Yeah, there we go. And then we should ignore check pragma GCC diagnostic ignored, and this is they sign compare. This is not our code. We don't want to care about warnings from there. Right, so we have somewhere struct scene being defined as a class. Class scene. Yeah. This should be struct. And that's all. Okay. Next up. Yeah, that's fixed. Okay. No, that's been fixed as well. Let's actually just rebuild this and look at the output then. So we should get rid of quite a lot of things. Yeah, that's way less. Okay. Yeah, so this can... Yeah, we're not using these at the moment. Comparison. Okay, this is not being used. In general, this code is all a big mess. So let's just get rid of the drop EVH code in general. Yeah, and this one we can do the GCC push as well. Here. So hashtag. Yeah, let's just copy the line here. And this is W. We sign compare, and we pop it here because these are all warnings that are not a real problem for us. This can go common code. Interesting. So how are we missing things? Oh, we're missing pivot. Okay. Sure, we can set that to 0. Oh no, we are actually setting pivot. What am I talking about? Missing field data pivot. initializer, yeah, but yeah, because these are vec2, so that's fine. Because we're passing these in. Interesting. Okay, well, I suppose we could ignore that. Oh, what? Why is it complaining about pragma once? What the? Right, so apparently there is something interesting with the pragma thing, so I'm just going to globally disable that. I think I can do that here. So if I compile again, I should get rid of a bunch of them. I think I did. Right, no, apparently not. I don't think it's this one. So apply. There was one. Control flow guard. No. No, cancel. I didn't mean to change that value. So there should be an option for code generation, maybe, to basically disable, to add flags to compiler in MSVC. However, I normally use the MSVC compiler and not Clang, so this is all a bit new for me. Yes, 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 not yes. Right, so I think it's under add. Right. So apparently it is this. However, it might simply not be a dash, but I need this. Right, does that help at all? No, that gives me more errors. Yeah, right, so notice it's file, okay. Right, interesting. So if I do this, do you now magically approve of this? Yeah, okay, that's fine. Cool, so we're just ignoring that. All right. So we can just do this. All right. That should get rid of another one, right? Oh yeah, this function is yeah, we can get rid of this function in general. It's not working. Anyway, so we can get rid of that and look at that later. Yeah, so this one is also complaining about things. So pragma, let's just ignore this as well, because this is fine. And it is way missing fields initializers. Okay. Right, so there should be a size t, I'm guessing, instead. Let's see if that gets rid of it. Yeah, that does. And sure, I'll do the same here. Size t instead of an integer. Okay. Oh, so this should be a uint 32t instead. Yeah. Int and unsigned. So this would be unsigned. Okay. And that should be fixed. There we go. We completely cleared the output list. Okay, that's great. For some reason, I'm still having an error here, but it's compiling fine. I'm no member of... It's there. Oh, could it be because it's not in the... Interesting. So where is the std clamp from glm? Just glm clamp. So it's under, I think, glm core. Okay. So we can include glm / common. Right, let's compile again. We had like 20 something, 29. Okay. Dots is, I'm guessing, as well. Right, so glm dots. Where is this part of? Geometric functions, okay. Sec include glm / geometric. Okay. So it's 29. Okay, that's a bit less. Oh, we don't have memory in here, okay. Include memory. So assert if results does not equal. So result is less than 1. And I think it should be the same here. Results, this could be just if it does not equal 0. Right. Yeah, that's not mine. Right, there's no triangle, but that's fine. This all passes a reference, so we can just say struct triangle. Is this seen as a class before? Oh, it's class, okay, sure. So that's forward declared now as well. Yeah, we're getting rid of them. Yeah, so apparently it is complaining about these, however, I'm not too sure how to fix these. Wait, this one should be ignored by the compiler, but that's fine. And then include triangle. Right, I'm just curious how it compiles in the first place. Include memory. Yeah, the result is actually used now. Okay, let's recompile that and see. I think we got rid of most of the errors anyway. Yeah, it's mainly gone. So the only thing I'm curious about is this error, but I think it's just MSVC being MSVC, you know? So I think there isn't that much that we can do about that. So next up, I wanted to look into, yeah, the hid info thing, right? So tuple can go, this 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 can go. I think everything beside this file, right? And we pin this, right? So this hid info, right? What does hid info contain? It contains a actually shared. So this intersect. What did this return? A const triangle pointer. Okay. Triangle pointer, triangle. Oh no, we can't name it that. So we can do call it hit triangle. Const. And I think this we sort of says a shared pointer. No, I can just forward declare this. I think it's struct model. Right, and this is hit model. Right. Then a glm vec3, and then we need to include that as well, of course. Stack include glm / vec3. World intersect, then another glm vec3 local intersect. Okay, and then instead of basically all of this, so we can put here the material as well. Sure. So a const rt material pointer. Material, yeah, we can just do that, a bit easier to access it. And no, I think this is fine. So then we can get rid of all of this and pass in a const hit info, for reference hit info. Right. And then we need to change that on the other side. And this apply shading now takes in this massive function. Sorry, this struct. Okay. So then in here, I want to do the following. Right. I want a hid info, Right. And then these can all go. Yeah, the boolean can say sure. Model can go. No, you know, hid info would actually contain the boolean hit. Bool hid, yeah. Then we can get rid of this boolean. And then we can have a float distance as well. Right. And distance can go as well. Right. So hid info.distance is equal to infinity. And hid info.hit is equal to false. Just explicitly saying that. Then this can go and this can go. Alright, once we hid something, so if hid info.distance, then hid info.hit, then hid info.distance, hid info.hit triangle, hid info.material, and hid info.hit model. Right. Then I wanted some other things. So we have the world intersect and the intersection. Yeah, what is the transform distance? Yeah, okay. So there's the inter, and local hit can go as well. Right. Then, so this is local hit. And local hit is times that, okay. And then hit info local intersect is equal to local hit. And hit info world hit intersect is equal to world intersect, right? That's the transform, and we move it back, okay. So then if hit info hit, then we simply say, hey, pass in hit info. Okay. Then hit info dot material, hit info dot local hit, local intersect, and hit info dot hit triangle. Then hit info dot world intersect. No, sorry. Oh, the material, right. So hit info dot world intersect, hit info dot hit triangle, hit info dot world intersect, and hit info dot hit triangle. Okay, cool, there we go. So the only, you know what actually is important here? So this is the normal, but the normal would be transformed, right? So we're getting the normal here twice, right? Yeah, so this should be replaced with normal. And normal should be equal to, normal is equal to glm normalize. No, I don't think I have to normalize it. Maybe. Glm normalize, hit info dot hit model dot transform dot get transform times normal. And then there should be another, oh right, there should be a glm vec4. And since it's a direction, it should be 0 to 0, comma 0 to left, right? And I think that would actually do it for shading. I think that it would actually be enough to fix it. Yeah, oh, that actually looks way better. I mean, the light is way too bright, right? But I think the light before was way too soft because the calculations were wrong. So I think if we do this, bam, and then switch it back to like 50, what's way less bright, we should have a good potato. That looks way better. It's still very, very bright, but that actually looks like proper shading. Let's move this up by like 10 units, right? I think now we should get rid of the biggest white spot. Yeah, there we go. That looks like proper shading and texturing. That's okay. That's big. Cool. So now we have yeah, a actual proper potato. Okay, that's cool. So now I actually want to go to Git Kraken and submit this code that we made, because we fixed a bunch of things here, and I think it would be nice to just submit this and get a clean slate. So let me put Git Kraken up. Right. There we go. Yeah, it's solved now. So there is this bug now, and that is fixed. Cool. So then on the thing here, we can stage all changes. Yeah, and this is fixed warnings and fixed transform bug. Right. I think it would be cool if we could have a bug trigger. Git Kraken might actually have that. Right. It might not have it. We might be able to in the description. So I'm kind of curious if we can assign a push to this or something, but I don't think so. But that's fine. Okay. So we fixed the texture issue when we did anything with the transform. Oh wait, sorry, my face is in the way. Oh no, never mind, it isn't. What am I saying? You can actually see it. It's a bit confusing because I'm used to things being on the bottom right, because it's for me, right? But the OBS scene, everything is a bit jumbled around, so you guys can actually see Git Kraken correctly, right? Like, although for me it looks like it's hidden, but it's not. Sorry. Fixed texture issue when we did anything with the transform. And what else did we do? We fixed, we suppressed, or fixed warnings. Okay. So this is basically some cleanup, and then we push. Look at this on source control. Cool. That should be it for this, and then something I actually want to do before we continue is, if you look at my main, right, it's become quite it's become a too big main file. I think we have way too many includes as well here, so I want to get rid of some. So what I've been thinking is it's time to make a proper application type of structure, so that things are actually going to be a bit more organized. Right. So sorry, I was distracted by a bit, for a bit. Then we add a class, and this is going to be, yeah, I think we could just call this application. All right, and this should be in the include. This could just be, yeah, sure. And I think with the CPP file, it can be just in the main, like the main directory there. So create. Right. So we have the class, and this is, yeah, this should just include application. Oh. And same for this. So this, I kind of want them to use these PCH, right? So there's should be a application. Oh. Application. It should all be public. And this can just be a default. Then we give it a init that I don't think we're going to give any arguments. This should be fine. No, why can I not generate? Oh, sorry, this should be a void. Oops, what am I doing? Right, generate implementation, initialize, cool. Then we have a private void void tick. Yep. And this will be, right, so this will simply be the while loop, right? So in the main, I want the, yeah, let's begin moving things. So the first thing that our application should have is, I would guess, an ability to manage scenes, or at least initialize the scene, right? Oh. Right. So we would say, we can have this here. So we have, in main currently, we have the scene. Yeah. So this is in private. So we, oh, and this is all under the RT namespace. And then there should be RT application and RT application. Okay. And then we forward declare struct scene. Okay. Oh, and this is m.testing, right? And then initialize, we say m.testscene equals std make shared rt scene. And then we do need to actually include scene. So this would be core.scene. Okay. And this is all scene stuff. So we can all move this here. And this is now not called test scene, but it's called, yeah, it's, sorry, yeah, it's still called test scene, but slightly different. Okay. So we need to include the resource manager, because otherwise we're never going to be able to load something in. However, I don't want to create it here. It should be a shared pointer in here. So this should be class resource manager. Manager, cool. And then RT can go, and RT can go, and this is m.resource. Okay. I think we can actually have a non-default constructor. No, I think that's fine. So in here we will say m.resource manager equals std make shared rt resource manager, and then we include that there. Cool, that's fine. And then we need to set up the active camera. Yeah. Okay. Application. And this would be class camera. And this would be m.current camera, I'm guessing. Right. So is m.current camera, and we initialize it here. And that's equal to this line. And we just initialize that. Cool. Then we would have a window as well in here that we need to create. So that would be a unique pointer. And this would need memory actually. Hashtag include memory. Okay. So we would have a std unique pointer of type window. So this would be class window. And we have m.window. And then m.window equals std make unique window. And then I think I just pass in these variables. And then I do need to, of course, include the window. That would be under graphics / window / window. Okay. And then I need the camera as well. I think it's under core. Camera, yeah, okay, cool. And then we can pass in the m.camera dot m.window dot get size. Yeah, there we go. Then we need to include point light. This can go as well. Some debug code. Kind of want to get rid of this as well. So this is our buffers that we're actually dealing with. Right, now these are something else. These are for the something I tried. Right, however, that got deprecated. Pretty much. Right. Okay. But we can still say in here we actually do want one. So we have the glm vec3 pointer. No, this would actually, I would move this to the window. So in the window, we can we have a glm vec3 m.buffer. Yeah, let's just go buffer. And in here we malloc this. Right, so in window.h we need to include glm vec3, of course. And this is a pointer. So when we initialize the window, so in an init window, I want to say m.buffer Right, and that is m.windowsize.x and m.windowsize.y. Okay. And then there should be another function called glm vec3 pointer get buffer or get screen buffer. Right. And that simply returns return m.buffer. Okay. Well, okay, it just took a while for the thing to respond. Okay, sure. So this should go. Then the application should have a Raytracer. So that should be a unique pointer as well. Raytracer and tracer. Right. And then in here we make unique the Raytracer. Make unique Raytracer. Then of course we need to include Raytracer here. Yeah, and we can't do this in here because we actually need to pass in the scene that we're using. So this would be test m.test scene, right? Then what else do we have in the main? Right, we need to initialize the job system, and this is 0 as well. Okay. So main application.cpp, we initialize the job system. Yeah. So this should be moved up as well. Okay. So then the job system is initialized. Cool. However, actually, I want to do this at the very start, not at the end, because that would allow me for initializing it in other places as well. Okay. Then this should be moved here, right? No, I need more. Okay. Cool. Copy this and the application here, and then in tick. Right. And then we do want a float delta time. However, we want that to be a local variable. So float m.delta time, and this can go. And then m.window, and then that is a pointer, right? And then this calls tick. So then we need a timer, and we need OpenGL. However, no, I actually don't want OpenGL in here. Oh, however, we do need them for here, sure. It can stay in there. No, sorry. However, I don't want this. Yeah, no, that's fine. Oh, this is m.window. And chunk size will be gotten later. And that is get. Right. Oh, we can't actually pass it around because it's a unique pointer. Right, now there's actually a problem because only one person is allowed to own the Raytracer or hold a reference to it, right? What in this case is actually a problem. So this should be a shared pointer. However, that can be fixed here. Then instead of make unique, it would be make shared, right? And then we don't pass in the tracer, we just pass in, yeah, no, we pass this in by reference. Okay. and then we pass in m dot current camera and m dot window dot get buffer. Wait, why can't I not do the get buffer? Oh right, I can't just only pass an m dot window, right? And I should be able to pass a reference though, I think. Right, C++, pass reference to unique pointer. Huh? Oh, I think I'd have to do std ref because these are like weird S types. Yeah, that looks to work. Okay. I think I do same with here, std ref. And same with this. Right, so do you allow me to do this? So just comment this out. There should be a valid lambda. No. Okay. Tracer.get. So I do think I can do it like this. If I do funky stuff, right? So I want to dereference this and pass this. However, that doesn't work either. So pass unique pointer to lambda. Right, how do I do that? Okay. Okay, so it can't be a unique pointer at all. That's kind of a pain. Okay. So pass a shared pointer to lambda. Right, okay. No, I see. So I would make this a shared pointer as well. And they would all just be shared pointers. Okay, sure. I can live with that. And then this is make shared as well. Right, and then we should simply pass... Where's the lambda? Right. So nothing fancy here, right? We just pass this in as a copy. Because we can actually very cheaply pass copies. Because it's just a... What do you call it? It is a... Huh? Interesting. Can I... Do I... Okay, I think I have to pass this. What's fun? But that we can manage. So if I pass in this, okay, and I want to capture the rest, I guess. Okay, sure. So chunk size should be defined here as well. That's currently a define. However, I want to move that to a integer. So that would be a uint 32t chunk size, or m chunk size, just equal to 8, right? And then that should be plus equal chunk size, or m chunk size. Right, and then I want to copy the rendering, the render job, and then in the application, there should be a lose function, right? So this should be uncommented. So I want to pass in m.tracer and m.camera, and I want to pass in this, so m.window dot get dot get pixel or get screen buffer, right? And actually think about this. No, I think this can now actually be unique pointers, and that should still be fine. No, I think that would actually be a problem, because that would mean you're transferring ownership, so that would never work. However, shared pointers are fine. Right, and this wouldn't take in this. This would take in a const yesterday shared pointer of RT tracer. That would be tracer. And that would be the same for this. This would be, oh wait, where do we take in the camera? Okay, right, so this would be reference and RT camera reference. Okay. And that would be this, right? So then the render job should not complain, and then right, so what else did this counter? So why is this still complaining? We have the capture, then we have this. So that's the Lambda part. Then we'll check. So we're passing in the tracer, position, chunk size, then the win size, yeah, current camera, and the buffer. Okay, cool. Function has 2 parameters. Oh, yeah, of course we need a counter. Sorry. So this was correct. So we would instead of this counter, yeah, no, we would just need one counter here, right? So we need to include atomic, and then we have an yesterday atomic of an yesterday, I think just an int. And this is m.counter, right? And then we pass in m.counter. Right, sorry. Then that job is created, and we can still do this to make it a bit more readable what the Lambda is doing, right? So now it's a bit clearer what the Lambda is doing. So then the job is generated, and then we wait for m.counter here. Okay. Is there anything less in the main? No, there's just the render. What is interesting? Why is that a separate job again. Right, I remember what is a separate job. m.window.draw pixel buffer, and that would be m.window.getSize, and that would be, yeah, so that, I still need to cast it to a void pointer, and that would be m.window.getScreenBuffer. Okay, and then m.window.update. Then this is gone. This is not needed either. Okay. And we can't do this, of course, but we can do m.delta time and then m.delta time. Okay, cool. So now this should. Oh, you know what? Oh no, I'm so bad. Sorry, guys. I just realized I've been streaming. Get Kraken instead of Visual Studio. That's so bad of me. Right, sorry about that. I really didn't mean to do that. Sorry, you guys couldn't see the code the entire time. I've been rumbling on for so long you guys couldn't see a single thing I was doing. So sorry about that. Right, so this should now compile. Okay, yeah, that compiles. There's still the one weird error that apparently is not a problem. Oh yeah, this is not going to do anything. Yeah. Because the yeah, so we don't need this at all. We don't need this either, I think. No. I think the only thing that we need is hashtag include application. And then we have RT application app or application, and then application dot init or initialize. Right, and this file doesn't take the main doesn't need the PCH anyway, so we can just say precompiled header, not using precompiled header on all platforms. Okay. And recompile. So now this file isn't using precompiled headers. And then that should run. Okay, there we go. Now we have the potato again. That's beautiful. Of course, it's not moving. It's rotating like, or not rotating like before. But that's fine. What we can do is to make it move again. So this is a. Yeah, sure. And then cow1. So this is a bit dirty, but for now this is fine. Right. This is a bit hacky, but it's fine. Right, and now it's rotating. Cool. That's really all I needed to do. Okay, so that's actually perfect. So I'm actually something that's interesting is that my CPU, my new CPU, it's actually doing really well. Like we can render this in quite high FPS, but the performance isn't being hit at all. Like we're still running in like the 70% region. That's interesting. So that means that there somewhere is a bottleneck, or at least it's not fully being utilized. Things have to wait on each other. What's interesting. So I'm wondering what happens if I increase, for example, the chunk size to 16, right? Does our FPS increase? Just something I quickly want to test. It does. Okay, that's a massive difference. Okay. So it seemed the new CPU, it's 8 was way too little. Right, so what about 30, 32? Would that be any better still? No, I would say that's a bit worse for sure. I think 16 is in form of the new CPU a good number, because that's running like insanely fast. Yeah, I think this is the best mix. This looks good. So the next thing I think we should do is get rid of the print statements. I want to get rid of the console, or at least for this, because logging things like this is painfully slow, and there are better ways to do this. So what I am suggesting that we do next is work on I'mGUI. So I'm just moving that in Gitkraken, and it's time to set up I'mGUI. Right. So what did I need to do to set up I'mGUI again? Right. So we need I'mGUI. Then we just download that code, download zip. Okay. Okay. Cool. Then I'm just setting up the files. In File Explorer, so give me a second. So examples, OpenGL, no. I think there's just a GLFW, okay. No, I don't think I need anything for that, potentially. No, I think that might just work, okay. Then in the source, I need graphics, I'mGUI, and then the last remaining files need to go in there, okay. And while we're at it, I can open the OpenGL GLFW example. And just open that main file so we can see that, right? So we need to add some files. So we need to add a filter, and this would be I'mGUI. Okay. So in the source files we add existing. So for some reason you guys can't see this. What is kind of interesting. Ah, okay, so no. Oh yeah, this is the correct thing. Okay. So we go to the source, graphics, I'mGUI, and we include all of these files into the project. Then we do need to go to all of these properties. Then you guys can't, of course, see you guys cannot see the property pages because why would you? Okay. And then not using precompiled headers, right? Because these are not my files, I don't want them to use the precompiled header that I made. That doesn't make sense. Then in headers, we do the same. So we make another filter called I'mGUI. Then add existing files. And then instead of source, we go to include graphics, I'mGUI, and take all of these. Right. Then, ooh, I do actually realize I want the I'mGUI docking branch. Right, let me actually get that branch. Right, and replace the files real quick. So that would be I'mGUI. Yeah, replace, and then go back, include graphics, I'm GUI. Yeah, okay. So there's a replacement with the Docker branch now. So nothing else has to be changed because it's still the same file, right? We just replaced it. So this should be the OpenGL example. Okay. But this doesn't look like the OpenGL example at all. Huh, maybe it is. Okay. Oh, this is the main, right? So what is this? The callback. It's okay. Oh, is this a function that he made? Yeah, okay. So I don't think we have this actually set up in the window. So window. No, we do have an error callback. Okay. Yeah, and that's actually set up. Okay, cool. So then we set up that, and then we do the hinting. Sure. Create the window. Do we do this? So DLFW make context current. Yeah. Okay. Yeah, and then we set up I'm GUI, and I think this has some dependency. Yeah, okay, so I think it's only this that we need for the I'm GUI layer. So let's go back to application. Then I want to add in imgui.h. I want a new filter, and this would be layers. imgui add layers. And then we want to add a new item here. And this would be include graphics imgui layers. And this would be a header file, and this would be an I'm GUI layer. Right, and this would be in their namespace RT as well. And this would be a small class. So this would be class I'm GUI layer. So what does this class have? It has a constructor that is default. Then it has a virtual update that accepts float delta time. And this is equal 0 because it's interface. And it has a virtual destructor. Oh, so virtual void updates, right? And a virtual I'm GUI layer. And this is equal to default as well. Okay. Then the interface is complete. And then we need a class, and this would be the I'm GUI instance. And this would just be under graphics, sorry, no current tracer. Oh, you can't see the window anymore. It's so annoying. Right, so this would be include graphics I'm GUI, and that would be just in here. And same with the CPP, but then it would be not in include, it would be in source, graphics, I'm GUI, and then just there. Okay. And that would be in the namespace as well, namespace RT. and then a public GUI instance. So this is equals to default as well. Right, we do need a destructor. However, I want this, yeah. This would be under graphics. I'm GUI instance, and that should work, right? And then we can create this now. Then we have a void at layer, and this would be a unique pointer. Memory. An std unique pointer of type I'm GUI layer. Then we do need to forward declare that. And that would be a reference layer. Right. Then we need to include vector here as well. And then we have a private std vector of std unique pointers of I'm GUI layers. This is m.layers. Oh, and this should be forward declared outside of the class, right? RT, yeah. And then this should m.layers. Why is this complaining? So apparently it's not happy with that for some reason. So let me just... Oh ships, I did this wrong. So this should have the thing, and this should have... Right. And then the destructor needs to be constructed again, right. At layer, so m.layers.pushback yesterday move layer. Right. And this takes it in as a R value. I think we can just do it like this, because we don't actually take it in the constructor, so we don't have to move it here, but in the at layer it gets moved right into here. Okay. And then we do need to include include graphics I'm GUI layers. That, and then that's cool. Then we need a void update, and this takes in just a float dollar time, and this is gonna loop over all for each m.layers, and this can be an auto ref, and this is layer. And then layer dot update. Yeah, can I do this? That should be okay, because we have memory from here. Did I misspell the GUI layer? I might have. In the instance, right, so it's the... Oh yeah, I'm definitely misspelled it. Right, no wonder it's not very happy. So in that case, we might actually be able to take a ref or a universal reference here, and then do the update, right? So we still don't have to move it, because it's an R value. We simply say update. Right, okay. So that's cool. And then in the application, we want a std unique pointer. This time we do actually want one of a class. No, sorry, we need to forward declare that as well. class I'm GUI instance. This would be I'm GUI instance, and that would be mdod I'm GUI instance. And then we make this shared. We also make private. So mdod I'm GUI instance equals std make shared. Sorry, make unique. I'm GUI instance. And then we include that. Graphics, I'm GUI instance. Okay, cool. So if I now want to add a layer, no, sorry, I forgot something important, right? For I'm GUI to work, we actually need to set it up, right? So this doesn't actually, once we construct this, we actually need to pass in a std shared pointer to the window. No, sorry. Oh, no. This is fine. Sorry, it was the instance that I care about. So this isn't default. This is in the here. So this would be an std shared pointer of type window. This reference mdol window, and then this is class window. Okay, then we copy this code from the main. Okay, and then we need to include a bunch of ImGUI files. Did I have to? I think I had to define something, right? No, I didn't think so. Okay, that's cool. So this is all correct. So we need the ImGUI implement in it for OpenGL. Okay. Let me find where it is. So under, I think it was under examples, right? Is it libs? No. Right, I found it. Cool. So we're missing some files here. We're missing the OpenGL 3 implementation, the header and CPP, right? So that needs to go in there. And then source. Okay. So that's an easy fix. So I'm GUI add existing item, and that's this file. No, so that's added, and then we do the same for the other one, but then we include the other CPP, the other OpenGL implementation, and now we can include this, and it works. It should magically work. Is this? This should be there. Oh, it ships. It's not the OpenGL 3 implementation, or I think it might be as well, but I think we need both. Yeah, so we need the implementation GLFW as well. Right. I missed that one. But then again, that's an easy fix as well. We just need to get that file as well. Okay. So I'm GUI add existing item. glfw, add. Okay, we have that. No, we don't want to save that file. And that is the implementation glfw. Okay, there we go. So this takes the glfw window. So in window.h we want a glfw window pointer get window, and this returns no, this shouldn't be a struct, this should just be this pointer. Yeah, that's just return that. And then return m.window. Okay. And I think we want to save the, so in the main here, right? They pass in the GLSL version. Oh, okay. What is just this? Okay. Sure. We can just have that hard coded. I'm fine with that for now. So this is window.getWindow. We do need to include the window here. So include graphics.window.window, and then .getWindow, right? So now that is implemented. Then for getting the frames, there's only one more thing that we need to do. So we set up ImGUI. Then we need to call these three functions every frame, and then re-render it. Yeah. Oh, we need a bunch of other things. Okay. So let's begin with the. Yeah, let's just copy this entire thing. Yeah. Right. So in the updates, we do this. So if true, so we need a boolean. So bool show demo window, and that's equal to true. So all I want to do in this case is just get the demo window running. Or I mean, I want to do more, but no. So I don't want this. This can go. This can go. I don't want to deal with that. Yeah, no, we don't need this either. So this is the ImGUI render. This should all be. Yeah, no, we don't need this either. This is important though. So this should be on the very edge, right? So this is our update thingy. Then we actually do the rendering. So we can actually do update and then void render. And this is the rendering. Right, so we don't have the IO stored. So this is the... Right, so this would be... We do need to store the IO somewhere, okay. So we need... No, but this would actually just be the IO. Yeah, we need to include ImGUI. Sorry, and this would be m_IO. Right. So m.io. Yeah, no, this actually needs to be a pointer. Right, and I think this is a struct. Yeah. Because it's a pointer, so we have to, yeah, here is a pointer as well, and that way we don't have to include GUI here either. What's a good thing? And then this would be, yeah, void m.io, and this would be get the address. And why is this complaining? Wait, what? This should be fine. Did I do something weird? Yeah, add forward declaration. Oh, yeah, because it's not namespace RT, of course, yeah. And this is then m.io .config flags, right? And then this, okay. So then in my application, in the tick, right, I would, before I end this, I would then do the GUI update. So GUI instance.update. And, oh, that would take in delta time. And an GUI instance.render. Okay. And then we do need one more, because now when we set this up, we would need to pass in the window, window. And this should compile and run. No. Oh, that's actually a massive pain. Core graphics. I think I can actually do the following. So I can do graphics / GUI. Right, I'm gonna have to fix all those paths. I forgot about that. Because they're not in the normal file structure that they would be. But luckily it's an easy fix. We can just go through all the error listings and just put them in, right? Okay. One more. I think that is probably the last of it. I hope so. Hey, hello Beryl, welcome to the stream. How you doing, man? Yeah, so here currently I'm just working on implementing GUI for the Raytracer. Because it's going to be quite useful. So I'm almost actually done with that. So one failed because yeah, I'm doing good. The only thing that I'm noticing is that I'm very, very tired because yesterday during New Year's it was a late night. And it's quite late here, so it's like 9:30 p.m. Here. So application.h is failing. Okay. We can just include this. Thanks for the flow, man. Means a lot. I'm GUI and I'm GUI instance. Right, so I want to show you the progress that we did, and I should be able to once this runs, but I'm GUI is being a bit of a nightmare, and yeah. But I think I'm almost there, because it's just fixing these last few file paths, and then it should run. Because normally I'm GUI is meant to be all in the same file, right? The UI thing. And I don't have that because I have like my own folder structure. So all these include paths are completely messed up. Wait, why are we... Oh, I need to define this, I think. Right. Yeah, it is. You're not much of a coder yourself, or? Oh, okay. Okay. I don't remember. It's been a while since I've set up Tiny OBJ. Words. Think. I set up GUI, especially for OpenGL, because I don't tend to use OpenGL that much. I can take a look here what they do define wise. I might have the include order wrong. That could matter, maybe. No, it's in the correct one. Right, but I think the only thing I'm missing is the setup for oh, and the closing of I'm GUI. So in the destruct we need to call these, right? Yeah, I think we need to define that we're using, I think we're using GLAD, right? Graphics, OpenGL, GLAD, yeah, we're using GLAD, okay. But for some reason I can't find GLAD, sure. Right, so what if I include graphics, right. Does this compile? Yeah, of course, sure. Ask away, man. So RAM latencies. I'm not that big of an expert either, but basically the higher the latency, the slower they are, I believe. However, with most CPUs, it doesn't matter that much. Like, we're talking differences in like barely noticeable quantities, right? So I think, yeah, they would call it CL17 in your case. What is still pretty good, because I think you have CL18 as well. But for example, I know Ryzen CPUs like fast and fast timed memory. But then even then, right, we're talking about like in games a few frames per second difference, like nothing insanely huge. So yeah, it's basically the timing. Let me see if I can find a better description for it. Right, I think there is a, yeah. So hardware info, yeah. Yeah, so this number indicates the amount of clock cycles that it takes the memory to perform a certain operation. The smaller the number, the faster the memory, right? So 16 nanoseconds is faster than 17, but then like we're talking like 1 nanosecond, right? So it's not massive. So if you want, I can link you a big document explaining it. Here you go. So in case you want to read a bit more into it. Yeah. Oh, I'll put some extra stuff in there, but whatever. That link explains it quite well. But yeah, most of the time, just like any memory is like good enough, right? Oh, I could just do this. So if defined. Right. Okay. So apparently there is supposed to be, okay. Yeah, Lizard, I recognize you. Yeah, I actually started been doing some pretty cool things, I think, with the Raytracer. However, I can't show what I've actually been doing because the code refuses to compile. So, yeah, that does actually sound like coding, right? Right. Yeah. So I'm GUI instance. So it's trying to load. Yeah, it can't detect an OpenGL loader. Okay, sure. So in here, how did they do it? So if defined, right? I'm guessing. Right, let me actually go to my downloads folder and build the project. I'm GUI master. Yeah, I'm GUI extract. Because what I think is happening, let me build up this project, is that the project they have defines the loader that they're using. So I'm just gonna build the GLFW OpenGL3 example and check out the property pages there. Okay. Where did it put it? Okay, I think there. Yeah, this is true. No, it's okay. Retarget, sure. Let me, I'm going to share my screen in a second. Right, so it's open, share this, okay. So if we go to glfw OpenGL3, oh, it's struggling to load, okay. Properties. So what I'm thinking in here in the preprocessor, they don't have anything defined, okay. So set up a startup and build. Right, does this compile? Yes, it does, okay. That's cool. So sources, main. So if defined, right, so modern desktop OpenGL doesn't have standard portable header, yeah. Oh. Alright, if defined. So where do you define this? So if def, no, these are like standard definitions. Wait, so let me see where this is defined. Oh, so if has include. What is has include? Okay. So if defined Apple, no. So elif, if defined has include. Very interesting. So I think it takes this one, okay. Because this one is magically, so if it has included glue, then do this, right? Yeah, so it has apparently found glue. Okay. So it's trying to look for, oh, okay. Right, I see, right. So it can't find it because it's looking for glad dot thing, right? Okay. No, I think I can fix that now. So in here, we're not looking for glad.h, we're looking for graphics. Graphics slash OpenGL slash glad.h. And if so, define that. Okay. So is this correct? Let me double check this file path by checking it in the implementation. So hashtag include this. No, I misspelled it. Graphics, okay. Then we delete this again. And then we go back here and then replace this. So glad, let's see if this is anywhere else in the solution. Yeah, so this needs to replace as well. No, sorry, that's fine. Don't save. Glad.h. So that's one place. Yeah, and it's not gonna find this one, so now it is. Yeah, I think that's all. I think now it should actually compile finally. No, that would have been nice. So why are you still trying to find this? Yeah, you're a good one as well, Lizard. I will probably go sleeping as well relatively soon, because I don't think my eyes will be keeping open for much longer. Interesting. But yeah, thanks for the offer, Lizard. Hello, Bob Rose RTX. Welcome to the stream. I'm still trying to include this here. Yeah, so we're trying to currently. No, I'm not familiar with Python at all. I'm afraid. I think I've seen some streams with it, but like that's it at all. So sorry about that. I mean, depending on what it is, I might not be able to help with Python related stuff, but I might still be able to help with logic. So if ships, the OpenGL 3.cpp header, right? All of these shouldn't actually take in the precompiled header. I'm not using precompiled. Ooh, okay, that is completely not my area of expertise, I'm afraid. I suck at HTML, and I have never worked with Django before either. So I really don't think I could have been of much help there. With something game related, I might have been able to help, but with something like this, I really don't think I can. Huh? That odd. Where did the window fill? Huh? Oh, ships, the GUI instance is being made before the window. Right, sorry. We can't build an GUI instance without the window. Okay, there we go. This is awesome. Okay. So, oh, yeah. You can't see it because it's not showing GUI. GUI is magically gone now as well. Right, let me restart that and add the GUI window back. So, oh, okay, that's interesting. Add group window capture. Right, so we can see that we have GUI magically running now. However, what happens if I put GUI inside of it? It disappears because we're rendering. I think GUI second, but that's a very easy fix for my end. So instead of the, interesting. Oh, right. So the update should be done here. Okay. Man, I would love to help you, but I have never used Django or anything like that. Okay, right. So I don't need the GUI thing. Yes. Right. So now we can see I'm interesting. So we can kind of see GUI on the stream. So it disappears sometimes from stream. Okay, that's very, very interesting. Okay, that's a bit interesting. Anyway, we have GUI. I don't know why stream is not liking this at all. If I move it too much, but that's fine. Right. Sure. So the demo window is actually working. That's really I'm actually really happy about that. So now in here, we have the demo window stuff here, right? That we don't need. Right. We just want to update the layers that we have. And now we can create a actual layer as well. So add class, and this will be the docking layer. And this will, yeah, we could just do this, right? Include graphics, GUI layers, and docking layer. Graphics and GUI. Oh, this doesn't have a layers folder yet. And save. Okay. So now that gives us a docking layer, but we do need to fix this include path. So this would be graphics, GUI, docking layer. Or sorry, layers, docking layer. Okay, cool. And then we need to include graphics. Oh, graphics / GUI layers. GUI layer. Okay. And this is then a public GUI GUI. Oh, this is a namespace RT. Right. That's a public GUI layer. Okay. And I think I could use resharper to generate missing members. Okay. Awesome. Yeah, and I think for this, it's actually quite simple what I want to do. This is, I think, very little code. I can actually just rip this code from another project, because this is only supposed to basically be a tiny layer that all the other windows can dock into. Right, so like the code it has to do is actually very, very little. However, I forgot the code that it was supposed to do, because it had some interesting properties, basically. Header files. Yeah, docking layer. There we go. So cool. This was all the code that we needed for it. And now we need to include GUI. Yeah, I think that's just it. Okay. And I think so that is doc space. And then we call this doc space. Okay. Cool. That's done. Then in main, oh, sorry, application.cpp, we want to say in here, GUI instance dot pushback. Sorry, the add layer, std make shared. No, sorry, make unique. Make unique. And I need to include. Hashtag include graphics. GUI layers / docking layer. Right, and then we need to make an unique docking layer. I think this should compile as well. And now we should see a docking layer. Yeah, so you can see this tiny bar on the top. This will allow us to dock other windows into the screen quite nicely. So now I want a simple stats menu that will display some info to me. So this can be another layer. Oh, let me actually add the layers to the filter here. So we have the docking layer. This should go to here, just GUI. The docking layer should be in layers. Right, okay. Then we want to create a new layer. Graphics GUI. Right, another layer. Add class. And this would be stat window or stat layer. And then we just need to set up the file paths. Oh, why is none of the page is showing that it should? I'm really sorry about that. I'm just creating that file at the moment. I'm doing it via Visual Studio, but Visual Studio decided that we don't need the the files here. Right. Okay. Because there is the there's the add class thing. Oh, the add class is just black. Okay. Sure. That's such a shame. I really hope that would have worked. Okay. Anyway, I've created the class. And now we can see it. Okay. So this would be graphics, I'm GUI, layers, docking layer. No, sorry, stat layer. And then this is under the namespace RT as well. And now we need to include the base class. So include graphics slash I'm GUI layers, I am GUI layer. So this is a public I am GUI layer. Then we need to get the missing members. Right. Menti, thank you for the follow. Hope you're enjoying the stream. Right, so GL, then we need to include I'm GUI as well. Let's check include graphics, I'm GUI, right. So this would be I'm GUI.begin, and this would be stat window. And then I'm GUI.end. Right. Then we want I'm GUI.text, and this would be std string FPS, and that's equal to FPS plus std to string delta time, and then fps.tstring. Oh, and then plus /n. I think, yeah. And then we want another I'm GUI.text, and this is very similar, but this is time per frame. And that is 1000.f divided by delta time. TPS. As we would TPS.cstring. Then I want one more thing shown here. So this would be a private float delta m.counter and un32t m.frames. And this is equal to 0, and this is equal to 0. And then a float m.sample period. And this is equal to like 2000 milliseconds, right? This updates every 2 seconds. So m.counter plus equals delta time. And if m.counter is greater or equal than m.sample period, then actually this should be done at the end, right, to reset it. So m.counter plus equals this, and plus m.frames. Okay. And then m.frames equals 0, and m.counter equals 0. And this is average. And this is this is this, and this is delta time. and this is m.counter divided by m.frames as a float. Right, and then I want another one here. Oh, sorry, and then we do need to print this text out as well. And this is average.cstring. Then I want something similar here for the FPS. Average FPS, and that would be 1000 divided by this. Right. This would be average FPS. Right. However, I think this is a bit weird if it's stated like this. So we will do this first, and then we will do the average numbers. Then in application, we can add this layer as well. Graphics, GUI, layers, stat layer. And this would be set layer. Right. So then we just add these layers, and then it magically should show up. There we go. So now we have a window that we can dock, and it shows up here. Oh no, ships. Yeah, we can put it just like on top, right? And this is now our FPS counter. So it shows the current FPS and like the average here. So now we can get rid of the stupid and slow as hell printf that we don't need anymore. And now we can run it again. I don't think it will make that much of a difference because printf compared to like what we're doing is nothing. However, in general, printf is quite an expensive operation. What I don't like. Oh, wait, yeah, the average is still fluctuating quite a bit, ships. Right. So we need another float. What would be average in the set layer, sorry. So we have a float average. And this is equal to 0. Right, and then we don't do this, but we say divided by average. Sorry, m dot average. And then in here we calculate, so m dot average is equal to m dot counter divided by static cast float. Static cast float m dot frames. However, the only thing I'm not sure about is in what type of format I'm getting delta time, because I think I might get it in seconds. So I have to double check that. No, okay, this seems actually to be correct. I think it's, yeah, it's in milliseconds. Of course it's in milliseconds, because the rest would have worked. Right, so this is really awesome. So this is working. So this will be a bit stabler. So we get the real FPS on top, and then we get like the average showing here, right? In a bit less updating in your face kind of method. And now we're getting rid of the console as well, what I think is so fucking good. Because this looks so much nicer. Instead of the big ass console that oh, chips. Instead of the big ass console that does everything for us. Yeah, so cool. Now the Raytracer is working. So what we actually managed to do today was we fixed the shading, we fixed the lighting, we got GUI implemented, and we got docking working and a very basic stats window. So we can do some pretty cool things now, or we can really easily add things on top of this. So what we can do, for example, is we could make a trace pixel. So you could click on the screen and it would trace it. You don't have to have GUI for this. We could also have a button, right? So you could say I want pixel 200 by 500 and then trace, and then it traces that pixel for you, right? we could technically do quite a bunch of things for this. So we could resize the window as well. So I think we could actually add. I think we can actually add resizing support. No, I think we can definitely do that. So, no, we can definitely do that. So in the yeah. So in the window, right? So it's going to update, and then, but that's at the very end, right? But that's fine. So what we can do, so the update, right? Yeah, swap the buffers and pulse the buffer. Okay, but after that, we can actually resize this pixel buffer. Okay, sure. So I think we can catch a resize event. So glfw on resize. You know, I think we just need to. I think we need to set it up here in the setup, right? So init window, I think there is the glfw on resize on window resize on size window. Okay. Apparently I can't see it directly, so I have to Google real quick. So glfw resize event, because I know you can set a callback, I believe. Cool. Right, there we go. I found it. So this is the function. So yeah, and this is the function that it has. Right. However, what we can do, what's kind of cheesy, we can make this a lambda, I think. So we pass in m.window, and we pass in a lambda. So it takes in this, then it takes in these arguments, and this. I think that should technically be fine. Yeah, I think I should be able to. Maybe it's because it's this. Okay, yeah, cool. So then I can actually, in here, I can do, I can actually do what I wanted to do. Okay. So, I did a malloc, so right, so free m.buffer. And then I need to cast this to a void pointer, of course. Right. Right, I can't do that, but I think, however, I can. That's I had hoped I could pass this in the Lambda capture. However, it seems I can't. Okay. Okay. No, that's not gonna work. Okay, that's actually a real shame. However, I think there's still another option for me to do this. Right, so this is clearly not the way to go. Right, so undo, undo, undo. Set the window size callback. That's here, okay. And this is m.window. However, I think there is a function called glfw or window. Oh, window.get user. Yeah. Right, and I think we can cast this to a window pointer. Sorry, RT window. And then I can say RT window pointer window. RT window is equal to this, right? And then I can call a. The issue is, right. Oh, I can do something cheeky. I can do a. Because I don't think I can make it a friend. Because that's kind of the problem, right? I need to access private members, what I can't. Because I think if I do now, RT window dot. Yeah, I can only get the public members, right? But I can still do free RT window dot get pixel buffer. So get screen buffer, sorry. And then this is a void pointer. And then I can do a void set new size, and it takes in a unsigned int width and height. And m dot window size dot x equals width, and m dot window size dot y equals height. Right. So then in why is this inline? Ooh, this shouldn't be inline, but whatever. We can move this in here. And then it's RT, and then it's not inline. Okay, cool. Then we can call here RT window dot set new window size, width, height. Okay. Then I can do I can say get screen buffer, right? And that is equal to a new malloc of this. And that would be width and height. I think this should work. Why does this not work? Oh, right, yeah, so this is equal to that, right, so this results. But this should be fine. Oh, okay. I can do a glm vec3 pointer buff, and it's equal to this. And then buff is equal to this. Okay. Sure. So if I now go in debug, and this should trigger once I resize the window. And nothing should go horribly wrong, right? Okay. Of course it did. Yeah, so this is, yeah, our ships, okay. Oh, I might have to set the user pointer. glfw set window user pointer, right? And that's equal to void pointer this. And now it should actually cost, right? Because I didn't set the user pointer, so of course it's not going to find it, right? So of course the free doesn't work. I had hoped I could do that, but we can still. Oh, we could actually just make we just have a set new size, right? And in here, I don't actually know why we didn't do that just in here. We can just reassign this in here, right? So we can just say, yeah. So we do free m.buff and m.buffer is equal to the new size, right? Okay. That clearly doesn't help. But why does that not work? Yeah, that should be fine. Right, so when I oh, it's running a release ships. I need to run this in debug, so I can actually debug this. So then I do this, I resize. Okay, interesting. I don't know why that crashed, but sure. Abort. No, I'm trying to get the debug place. Can you please show me where you crash? Oh, you're failing in the here. Okay. How is that? Oh, sorry. The result does not equal. Yeah, sure. So the assert failed. Oh, right. It's only running in debug, of course. Right. Sure. So free buffer. Right. So we fill there. Okay. So there's definitely something going wrong in the freeing. Right. Yeah, it definitely seems we can't get the buffer correctly. What is a shame. So what if we do it differently? Okay. So then we have a boolean, a bool size changed. Right. This is equal to false. So m dot need to resize. So m dot resize, m dot need to resize is true. Then we take this, and then we say in here, in the update, if m dot need to resize, then m dot need to resize is false. M dot Windows size dot x and m dot Windows size dot y. So what happens if I do this? All right, resize it. Bam, it crashes. It's still in here. It shouldn't be in there. So we should simply set the new size there. Oh, that was why it was crashing, right? Okay, no, right. So this doesn't have to be in the update, right? We're simply trying to free the buffer twice, but obviously is going to crash, right? Because that shouldn't be needing to be done ever. However, no, we still actually... No, I think this is fine. I think this is fine. Yeah, because we update before we actually render. We pull events, I think, or after we're done rendering. So it's fine. Yeah, this doesn't crash. So now we can make it full screen as well. Oh, and it renders a full screen as well. Okay, that's pretty awesome. I mean, the FPS dies, right, when I do it, but whenever I make it really tiny, the FPS goes up. Okay, that's pretty cool. But that wasn't that bad to add. So now we've got resizing going. But I'm actually really impressed by the new CPU, because this is like running on debug mode, right? In release, it's actually blazing fast. I mean, I think, right, compared to what I did last year. I'm quite getting proud of this, I should say. So this is running at 60 FPS, one model. And if I put it like this, yes. Let's run at 1200 FPS, right, ray tracing. No, that's not really that representative of a model. However, it is a ray traced model at a, I would say, decent FPS. What I think is still cool, like 60 FPS. Okay, to be fair, okay, I have to admit something here. I am cheating a little bit. So if we go to here, I may be using quite a lot of cores to do this. It might not be very representative of what most people have in their PC, I think. So I shouldn't be that proud of these FPS, because I'm at this point. It's, I mean, even though it's much faster than my old projects, I am throwing a lot of power at it, like a lot of power. No, but that works. That's actually really cool. The resizing works. Yeah. So, oh, actually, that brings me to a good point. What is GitKraken? So let's actually review GitKraken. So we had AmGUI at us, right? With a frame counter, we have that. Then, wait. Why can I not complete this? Hello? Oh, okay, it just took a while to update for some reason. Okay. No, we haven't got the normal view. We don't have that either. We don't have scene info, and No, okay. Can I undo this, please? Oh, no, shh. I didn't want to do that. Delete. I just want to uncomment this. Oh, no. Okay. Why is it? Gitkraken is having a problem today. Okay, there we go. It's fixed. Does it now properly do the button? Okay. So I think Gitkraken was just having a bad day, right? So next up, we should have a normal view. Okay. I think we can actually do that very easily. So yeah, okay. Visual Studio, Gitkraken, close. No, let's actually make a push first while we're at it. So we can add this, stage all changes. So added, I'm GUI, and some layers, right? So what did we add? We added I'm GUI. We added a stats layer, and we added a docking layer, right? And I think that should be it for the changes. And then we can just push that to the repo. So by the way, the repo is also available online. You can just view the repo. It's linked in the about section. Yeah, it's in the frequently asked questions. I linked it. So you can take a look at there as well if you want to see all the code at your own time, give feedback, anything that you want to do. I would be open for anything. So if you want to take a look at the code, that would be the place to do it. Yeah, sorry, I got distracted. Right, so we need another layer. So we need layer, add class, right? So this would be the, yeah, you know what? Before I'm gonna add the class, I'm gonna go get something to drink because my throat is starting to get hurt. So I'm gonna go get some water, and I will be back in like a minute or so. So please be patient, and I will be right back with you. Radio. Alright, I'm back. So, yeah. I got my water. So this is a options layer. Oh, and let me remove the text, right? So this would be the options layer. And the CPP, source, graphics, I'm GUI, layers, options layers. Oh, and I'm seeing that these are all in the wrong filter. Okay. And I'm guessing this one got put, yeah. Okay. And we're missing the stats layer as well. Think I might not. Yeah, I haven't gotten stats layer one layer either. There. Okay, cool. So Trailing off, right. So this is namespace RT. Put this back, put this in. Then I need to go back here, fix this include path. Graphics, OpenGL, no, sorry, GUI, layers, options layer. And this needs to include graphics / GUI layers GUI layer, and this is a public GUI layer. Okay. Then generate missing members. Okay. And this needs to set a value in some way. So this needs a delegate. Yeah. Because I need to set functions, right? So, oh, it seems I'm still sharing my main screen, I think. Yeah, what? Okay, that's better. So we're gonna need delegates to handle function, well, delegation basically. What isn't that bad actually? So what we can do is I need this library from another project of mine. Perforce. Right. Give me a second, I'm just setting it up. And then daps, copy, paste, and then in the current tracer include I think this could be just there. And then I need one more file. Sorry for being distracted. Though I think this actually is this header and CPP. So I might have to actually include it into the project. Although I think it's templated, right? So I don't think it needs the CPP. Don't think there is like CPP code. Okay. So, okay, we need delegates. So there is going to be, I think, just one big event header that we can use in here. So header, new item, and this is going to be the events. And this can be no, this shouldn't be here. This should be in the just include. Okay. Right. So when you create this, right? So we're going to have type def for functions type, right? So this would be the type def. No, I don't actually. No, I don't think actually we want the events header. No, that doesn't make sense. Never mind, we actually don't need this. I do need to delete it then, right? Delete. So in the Raytracer, we're gonna add a new function. So we're gonna need a boolean here. Bool. No, we're just gonna make a struct here. Struct options, and this will have a bool show normals. This is equal to false. And then we have an options, m.options, right? And then in private we have a, sorry, in public we have a void set show normals, and it's bool set or set value. Yeah, set show normals, generate implementation, right? So that means m.options equals m.options dot show normals equals set value. Okay, so that's cool. Then when we create in the application, we have a delegate. Yeah. And I think this could be just a global. It's a bit nasty, but I don't know a good place for them to store them at the moment. So we would have to include signals/delegate. So we'd have a although I think this is still in the old namespace I have. So it includes signal. Yeah, okay. Yeah, this should be in namespace art. Yeah, I could just do name in namespace sig. Sure. So we could have a sig. No, okay. You know, no. I have a better idea. So in the options layer, we can just have a. We do need to include this here. So include signals. Oh, sorry, include signals/signals dot delegate, right? And then we have a public sig delegate of type bool, and this is m dot normal delegate. Right, and then okay, m dot normal delegate, right, and then in the application.cpp we say we don't need this. We say and then we want std unique pointer set layer. That's right. No, we need to add another layer, and this would be std unique pointer of options layer. Yeah, include please. Oh. Options layers equal std make unique options layer, and then add layer options layer, right? Because this gets taken as a thing, and then we move this value, right? However, before we do that, we say options layer dot normal delegate dot connect m.tracer dot now we do add rt sorry, this would be at m.tracer dot this would be rt tracer Raytracer dot set normal, and this would be an at, and that you would pass in m.tracer dot get. Right. Okay. And then we add that here. Okay. Then in the options layer, we would have the updates, and we would have an we need to include GUI, graphics, GUI, no, sorry, and this was just GUI. Then we have GUI begin, options, and then GUI.end. And breakpoints. Then an GUI toggle. How do I do a toggle button? A checkbox, okay. Checkbox, enable normals. Enable normal view, right? And this is private bool I'm not sure normals. And that is I'm not sure normals. And I think, and then if this, oh, and then we need to take the address, right? So if that's the case, then we want to say I'm not show normals, right? We flip it around. No, I think we don't have to. Then we just say I'm not normal delegate dot I'm not show normals. Okay. So apparently this isn't okay. Right, I think I know why. So I would need a bool temp is equal to I'm not show normals and yesterday move temp. Right, we're moving temp there. So now we should be able to toggle that. I hope. No, that would have been lovely. Right, so would this be sig? No. Hashtag include signals / signals / signal. Ifalialen, I think, if I pronounce your name correctly. Thank you for the follow, man. Means a lot. Alright, let's see if this compiles. Okay, there we go. That compiles. So now we should be able to, if we do this, it crashes. That's perfect. I mean, that isn't, but you know. This was what? Okay. Interesting. Oh no, okay. Right, yeah. I see the problem. It's of course gonna be null pointer, right? Because in the application the Raytracer is it's a shared pointer. Oi. Oh, we haven't made the Raytracer yet. Right, we'll make the Raytracer first then, sure. We can't set a value that. And we. Why does it immediately start tracing? Oh, and we're. I'm having some interesting dependency things here. Right, so this should go back there, where it was first. Then we take this and just move this below there. And that should be fine. How did this suddenly crash? Right, let me just close the console, because sometimes it messes up because the console is still open. And run this on debug, so I can see what's going on. Right, so models.size. It's kind of interesting. So how did the delegate suddenly break it? So I'm guessing if I go... Oh, no. If I go back to the application, right? And then in here, if I don't connect this, right, I'm guessing this would be fine. No. Oh, the active scene is suddenly... No, okay. Very interesting. So the active scene is here, right? Oh, I don't think we set... m.tracer.change scene, and that would be m.test scene. I think this isn't called anywhere else. Okay. How did that ever render before if we never assigned the scene? Okay, sure. So now I'm gonna move the Raytracer back up to the very top. Right. The tracer is gonna be created there. Then these two are gonna be created there. Uncomment, and now I should be able to set this value. If everything goes well. There we go. Everything for a checkbox, right? No, but we can actually do something cool now. So let me just double check this. Yeah. So this should be true now. Okay, that's exactly what it should be. So what we can do now, we can simply say if hit, so if hit is true, right? And if m.options.showNormals, then we do something special. We return hit info. That's right, hit info dot triangle, hit triangle dot get normal. And we would basically we would literally take this line, yeah, these two lines. So we would return this. Okay, and that would actually show us the normals instead. So we would skip shading, and now we should be able to view the normals in the scene. So let me put this next to like here. And then there we go, we suddenly have normals. Hey. Welcome Abud Gaming to the oh wait, that's a raid. Hey Abud, thank you for the raid, man. What were you how was your stream? Oh no, pressing all the wrong buttons. Yeah. Hello, Secret Mud. Welcome to the stream. So, yeah, for everybody who would just join from the raid, first of all, I want to thank Abud for sending the raid, and yeah, so I will update you guys with what I was doing. So I have been working on making a Raytracer, and this is what I currently have, right? So it currently renders simple models with textures, and it does this in a decent frame rate. I don't know how readable this is. Oh, no, wrong screen. If I take, yeah, there we go. So I can make this a bit bigger, so it's a bit easier readable, right? So we can render models in real time, although I am throwing an exorbitant amount of computational CPU power at this. This is running on a 16 core, the new Ryzen. So this is not very representative, but it runs. And this stream I've been working on fixing some issues and adding I'm GUI so we can have options like showing normals at runtime, and just have information as well during the running of the application. Because before, everything would be logged in the console, and it was kind of getting on my nerves. So, Abud, what were you actually working on before you raided me? Yeah, so now that is working. I actually want to retry something I have been doing before. So what I want to try is I want to try to draw the bounding volume hierarchy of the model. So I want to try something here. What may not work. I'm just thinking, oh yeah, no, this would need to be in the application, right? Not a great place, but for testing code, this should be okay. So in here, just before the window updates, right? We would get, we go over the active scene and the test scene. Right. So sorry, this would be a for loop, and this would be models, and this would be over the test scene. Oh, test scene. Dot models. Dot size. So then another for loop for e, and this would be triangles. And this would be models dot triangles, or dot get vertices. No. Oh, sorry. This would be model data dot triangles dot get size. Dot size. And then this would be for e, and this would be 3. I'm missing some info here, I think. Can I do this like this? Yeah, I can. Wait, I had a vertices thing. Oh, is it just dot? Oh, I don't have triangles included here, right? So it's never gonna find them. So you can include core slash triangles. Right. And because what I'm basically been trying to do is I wanted to visualize the bounding volume hierarchy. However, I've had issues with the projection before, but I think I might be able to do it now because I got some other stuff working. Okay, let me. Oh, is this? This is triangles dot y. No, this is triangles dot triangles dot get verts dot y. Okay, this is a mouthful, but this will return me with a glm vec3 pulse. It is horrible debug code, but that's okay. So now I have this. Now I need to project the point. So I need the GL begin here. GL begin, and this would be GL line, and I need a GL end. Right, and this would be a then I need to project the point. So a glm vec3 projected vertex, and this would be equal to m.camera dot get projection, I think, times m.current camera dot get view times this dot transform dot get transform times glm. Oh, right, this is getting a bit long. Times glm vec4 of pulse and 1.f. Right, and this should give me the projected points, and then I should be able to do a GL vertex 3f of projected vertex.x, projected vertex.y, and projected.z. And this should hopefully, so this would be the MVP matrix, right? And that would be times the position. But it's in reverse because the vector multiplication is right to left. So this hopefully should give me the outlines, at least of the model, right? What might be happening, however, we might not be able to see it because the image is being drawn over it. Right, so we don't see anything. Okay. However, I think if I take the inverse of the projection, I get something on screen. I suck at this math, so I'm trying my best, but I'm horrible at this. Because I did play around with this before, and I think I had something like this. I'm not seeing anything. That's actually a problem. And if I inverse this as well, do I suddenly magically get a model? I highly doubt it, but the projection thing has always messed me up. No, okay. So it's model, view, projection. Okay. I could try rearranging the multiplication. What could matter? And then this one would be in the front. And then, right. So this is transform times ships. We're right. I've messed something up massively, right? Get transform, glm inverse, yeah. Right, okay, that was not bad. So do I now get the model? No, okay. So let me put this to debug and see what kind of values I end up with the projection. I mean, oh, no, these... Oh, don't I have to normalize them? I might have to normalize them. Let me double check how I should do 3D projection again. So 3D projection, project, calculate MVP matrix. Right, yeah, calculating the final vertex position, right. So it would be, so in the projection matrix times the view matrix times the vector position. Where is the model coming from? Oh, you're moving the, okay, sure. So you're saying, right, so what I'm reading is that we have a GLM mat4, what would be view projection, and that's equal to m.camera, sorry, current camera, dot get projection times m.current camera dot get view. Then we have a GLM vec4. No, sorry, we just, yeah, vec4 impulse, and that would be this dot transform dot get transform times GLM vec4 pulse 0.1, and then pulse is equal to VP times impulse, and then it would be pulse, 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 right? And this should give us hopefully the correct projected point. Right, so there's still a lot of out of view. So I'm curious about something. So if I normalize position, does that magically work? No, okay. That doesn't work at all. So model view times position. Right, so somebody else is doing it differently. So they're doing the model view first. What would, I'm guessing, just be the model view? Yeah, that would be model times view times position. Okay. Because I did know I was doing something last time with the inverse that got me reasonable results. But I really, really hate this type of math. But it will be extremely useful to have this working, so I kind of want it working, if that makes sense. Because the order matters a lot as well with matrices, I know. Because we're supposed to end up with values between like -1 and 1, right? So even now we're... Actually, that's odd. So even if I normalize them, right? Why are they not showing up on screen? Because they should. Because this is a valid... I mean, I could just do a GL Vertex 2. GL Vertex 2F. And is there another mode here? Is there like GL... Yeah, there's GL lines. Right. Yeah, okay, there we go. Now we have the model. Okay, that's cool. So now I want to vertex 3F and do pulse.z. I'm wondering if that makes any difference or not. Okay, there we go. That looks correct to me. That actually looks correct, right? So if I now re-enable the potato, do I magically gain... Okay. Okay, no, but look at this. So we can see that they're very close. They're both spinning. However, I think it's spinning in reverse. But that is fixable. So the position is flipped and the rotation is flipped. Okay. So what if I do the... where did I do this? Right. So the inverse of the transform. So get inverse. Because that might have been my my mistake. Okay, that's better. Now it's spinning in the same position. I think I actually know why the projection is wrong. I think if I go in here, and this would be in camera get projection. Right, I think the up is wrong. So what if I do left-handed? No, okay, that doesn't matter. Because I'm pretty sure it has to do with the Y. No, okay. I completely wrong there. But they're at least spinning. Yeah, now the image is flipped. Okay. Could I? Interesting. Okay, right. So how do I flip them? Right. Oh, so I could just give in a negative FOV to flip the image. I think I could try that. There we go. That looks in the same position, but it simply seems the skill is wrong. I mean, there still certainly seems a bit more wrong, but this looks better. I think we're very close. So in the application, so if I do get transform here, right? I'm just curious what would change. Again. Right, so that doesn't fix it either. That will just fix the spinning. So it's definitely the inverse here, but could it be the inverse of the projection then? If it's not the case, it might be the order of multiplication. No, I think that's worse. Okay. So what if I do this first, and then this? Not quite what I was expecting, but promising at least. I am actually curious about something. What if it's correct? If it's actually correct, right? However, there is simply a differentiation between the Raytracer and the this FOV in the way it's being calculated. The race. So I'm just gonna try to see what happens if I increase the FOV. Oh, I think it's definitely that. And is the model inversed as well? Yeah, so I think we're dealing with the fact that we have different FOVs maybe. So if I increase this to, I think it's like 70, right? So if I change this to, say 90, .f, what happens then? Right, so it becomes smaller, okay. So if I do this to 30, yeah, it becomes bigger again, okay. So the actual value, I think it's, so what happens at 35? Because that should be half of the FOV being passed in. No, that's still too big, okay. Because this might, it might actually be that, or my perspective and the GLM perspective is wrong, if that makes sense. That they're producing different projection matrices. Okay. However, I think this would be. Do we have a real? We don't really have a projection matrix here. Yeah, because we are multiplying it by the view, but not by the. Okay. The projection, no, that's not it either. Interesting. So if this is just FOV, it's a decent approximation. Sure. So if instead I did the following, right? I go to application, and instead of going over the models, I go over the BVH. I can't get the nodes directly. That's a shame. Oh no, I could just do. I could just get the roots. Sure. Yeah, I could just get root. Sure, I could just create a temporary function here that would just get me the root node. RT BVH node. Oh, this is model. Whoops. It should be in the BVH. BVH. So we can just make a function here called BVH node get roots. And this returns return m dot nodes dot 0. Right, and then in the application we can simply say, instead of this, I want to do 2 only, and this yeah, so we don't do this either. This is a much smaller for loop. Let's actually keep this though, for in case we want to draw the model again. Right. So this would be, yeah, dot bvh dot we need to include the bvhn as well. Hashtag include core /bvh node, and I think just bvh, and then get root, and then pulse is equal to this, right? So glm vec3 pulse is equal to get roots dot bounds dot y. Okay. And now we should magically see the root node of the BVH appearing. Or at least we should see a line going from the two root nodes. Okay, that's pretty cool. So that now we technically can draw the bounding, the bounds. And this looks accurate enough. I think this should be fine for now. Because if as long as I know it's not perfect, it's good enough, right? Or I mean, as in that sounds wrong. I should say, as long as I know like what it represents, it's good enough. We can fix it not being exactly spot on later on, but that's not important, right? So what we can do is, instead of the get here, we draw the BVH. So this would be void draw BVH, and this takes in a yesterday shared pointer of camera, and this will be cam, and this will take in a RT model data reference. No, sorry, this will just take in an STD shared. Sorry, which should be a reference, an STD shared. This will all be const. Const, and this would be of type model, and this is model. Right, so we would draw the BVH for each model. Okay. And get root can go. So application, and then we would say, not this, not get roots, but we would say draw BVH, right? And we'd pass in cam, or m.current camera, and the model. Right. And then I need to copy this. And then this part can go the GL begin and the GL, sorry, the GL and the GL begin. Okay. And then in the BVH draw, this can go here. And oh, we don't have that. However, oh no, we simply have the model. So we can just skip all this and replace it with model, and then this with camera, and this with model. And this would be m.nodes.0. And this would be 2, right? So this would give us the same result. And this would be, yeah. And then we would do a GL begin, GL lines, and a GL end. And this should still give us the line. Oh no, sorry, it won't, because I did an oopsie and didn't remove this code. Right. Cool. So that has that draws the line for the model. So now I want to be able to draw a node instead of just the lines like that, right? So in the draw BVH, we would create a private function, would be void. This would be in here, a void draw node. Void draw node, and it would take in a const pvh node, a reference, and this would be node. Generate implementation. Oh, okay. And then instead of this, we would say that we draw a node, and .nodes.0 for now. We just want to draw the outer node. I want the ability to draw more nodes later on, but for now the outer node is plenty. And it should only be done once, actually. Right, draw node. So then, in the draw node, oh shit. And we need to pass this as well. And then cam model and this, right? So then instead of this instead of simply using this position, we need to do the following. So this is bounce 0. So this is left node, or sorry, left corner, and then we have right corner. Oh wait, is it because I was normalizing? I just realized. It could be that the normalizing, I shouldn't do normalizing. So, sorry, this should be equals and left corner, right, and then what happens if I don't normalize? I get nothing. If I normalize, I get something, or no? Okay. Huh? Oh, right. Yeah, I don't get anything because I only specify one corner. Sure. Yeah. This won't work. So, right corner is equal to this. No, I need to get this as well. So, left corner is equal to VP. Sure. Okay. So this would be m plus 2. And this would be our right corner, and right corner is equal to this. So we don't need this, we don't need this, and this would be m plus 2, right? And then we draw another one, but then instead we have right corner. We need to do more, but this is just to test that we have the model back. No, we don't. Okay. Of course we don't. It would have been too easy if that was the case, right? Does this get triggered? Yeah, it does. Okay, interesting. Interesting. So why don't I magically see the line anymore? Is it because no, they already had the normalize before. Like nothing changed from before, and the line is gone. Okay, what did I change? If I do just GL draw line, right, does that work? No? Okay. as lines, and then I draw the node, and it's 2 vertices, right? That should be fine. So, oh, oops, I didn't take the second bounce, right? No wonder it didn't draw anything. Right, so now we have the arrow again, right? So what happens if I don't normalize here? Does that still keep the arrow? No, the arrow is completely gone. Okay. I will normalize, no problem. So instead, I don't want to draw it like this. I want to draw this, but then I keep the y and the z the same. So this would be x1. Then we need 4 of these. So this would be x2, x3, and x4. So this would still be that, but this would be RCY, and this would be RCY. This would be, so yeah, still the same, and this would be RCZ and RCZ, and this would be RCZ, or sorry, RCY, RCY, and RCZ, and RCZ, right? So now we should see a box, like the X lines of the box. There we go, maybe. Maybe not. We're missing a bunch of lines as well. So the model was doing fine before. But we should see 4 lines, but we're only seeing 2. What highly disturbs me. So I think if I comment these out, it's not going to make a single difference. No. But if I comment this one out, it's going to make a difference. Because now there should only be the 1 line. Yeah, now it's the horizontal X line. Yeah. Interesting. So why does it not give me 4 lines now? It was working fine with the model vertex, right? Like, that was no problem. But with this, for some reason, it's complaining massively. I could try... No, that seems like a horrible option, because you want to batch them all together in one draw. Oh, could it be because they're not connected for some reason? All right, let me try something. So we start with this one, right? So this is going from left to right. Then we're going up. So this would start from RCX, and this would start at the right X, the left Y, and the left Z, right? That would go up. It would go up, and it would go up to RCY. RCY. And this would go up. So this would be Y1. And then we would have another one that would go from this position to the same X coordinates, the same Y coordinates, but the different Z coordinates, right? So this would go basically right, up, back. Yeah, but we're still missing the back, and it's doing really wacky stuff. Right. Interesting. So if I simply have... So if I simply draw the... so GL vertex 3, Vertex 3F, and this was LC X, LC Y, and LC Z, and then I did the other one, what is RC. This gave me the diagonal line, right? But this one works fine, I think. I'm just curious why with the model it was fine, but with this it suddenly isn't. What intrigues me. And I'm curious, because this is looking okay, but I'm not completely sure. Anyway, I think it might actually be time for me to head off though. Because I've been streaming for about, 3.5 hours now, right? And I'm quite tired because it's nearing 12 p.m. local time here. So it's definitely time to start heading to bed. So I want to thank you all very much for the stream. Abut, if you're still here, thank you massively for the raid. And I wish everybody a happy new year, and I hope to see you all later. Have a good night.